Hello, I'm Nina Guerra, your moderator for today. Thank you so much for joining us today to talk about the backbone of the industrial AI revolution, AI infrastructure. As we increasingly work to bring industrial AI to real-world systems, there's a very important infrastructure shift required. A shift that will enable infrastructure to keep up with extraordinary demand. And I'm so glad to be joined today by two guests who are shaping the transformation of data centers. First, Ruth Gratzke. Ruth is the president and CEO of Siemens Industry. Hi, Ruth.
Hi.
Thanks for being here. And then we have our partner from Amazon, Joern Tinnemeyer, vice president of data center engineering at AWS. Hi, Jörg. Thank you for being with us.
Thank you for the invitation. Pleasure to be here.
I think we could best start with the basics. So data centers are nothing new, but AI-ready data centers, that is something new. So I would start with you actually. What does it take for data centers to be AI-ready?
Sure. I think at AWS, machine learning, AI isn't new. We've been working on this for the last 15 years already. So, and for us, it really depends upon what our customers need. It's all driven by customer demand. And in this particular space, it's always about the scale. Can we work on a global level? And the flexibility that we need right now, or the fungibility of moving, say, from a standard air-cooled system, and we can get into that a little bit later, and what a liquid cooling system does for these newer data centers. And so it's how to thread that needle appropriately in the right spaces and do this at the speed that our customers want. Let me give you an example. Our UltraCluster systems that we have, our UltraCluster 2.0, this is 20,000 graphic processing units that we've put together with less than 6 microseconds latency, and we did this in 7 months.
Wow.
So this is the type of speed that our customers anticipate. It's the new level of technology that they want in order to meet the demands that they're requesting from us. And this is really fundamental to everything that we do at AWS. So we're ready to go.
That sounds really impressive. and Ruth, we also often use the term AI factories.
Yeah.
Can you share what this means and how AI factories differ from traditional data centers?
Yeah. So in very broad strokes, what we differentiate is between cloud computing and AI factories, so AI data centers. And even within the AI data centers, there is a differentiation. So you're talking about large training data centers. That is the holy grail. That's the highest level of sophistication. And then also inference data centers, ultimately data centers that run these trained algorithms already. So just to set the stage, broad brush. From an equipment perspective, what that means for a company like Siemens is that there are a couple of very fundamental shifts going on. And Joern already touched on a couple of those. So first of all, energy density. We're talking about very different scale. We're talking about power density increasing by a factor of 10, 40, like sometimes 80 times are being talked about. This means ultimately we're talking about data centers that can scale to 1 gigawatt very, very easily. To do this in a confined space, in a confined piece of real estate, the density, the energy density in this system needs to increase. To do this with traditional voltage levels and with AC current, so alternating current, is no longer feasible. So the industry needs to shift to DC technology, to direct current, to achieve this energy density. But this also means that we need to get the power of 1 gigawatt out of a very confined piece of real estate. And that means a lot of heat out of a confined environment. And this is why we need to see this shift from air cooling to liquid cooling to just get 1 gigawatt of thermal heat out of a building. So that's not trivial. So I talked about density. I talked about changes in the power structure. To make it even more fun, a traditional cloud data center runs millions, multiple millions of processes in parallel. For the electrical engineer in me, that means a very steady load. AI computing is very different. It's all these processors that Joern touched on that are running, and then they need to pause, exchange data. Electrically, this means a load profile that looks like we're going from a short circuit to open connection, so very erratic. And that's about the worst thing that we can do to the grid. And that needs to be taken care of. In addition to that, we have uptime requirements. a data center needs to be, an AI data center, specifically a training facility, needs to be up all the time. And the term we have there is 5x. So that's the nines behind the comma. So essentially what this means, there cannot be a failure. Reliability is key. That's a key challenge for the electrical engineer. So I could go on and on and on. But what the key point is, we're facing major disruption, if you want to phrase it negatively, or major invigoration of an industry that has been, rather dormant for the last 20 years. So for me, it's fascinating times.
It's very fascinating times. And you already touched a little bit also on this engineering challenges or complexity. Yep. Building this kind of infrastructure presents a lot of these engineering challenges. Can you tell us a little bit more about this? Can you elaborate here a bit more?
Sure. What a great time to be an engineer.
Yes.
So I find it completely invigorating in terms of the changes that need to take place within the industry. It's really quite fascinating, and to do this at the scale that we have to also do this at really presents that next level of problem. So we touched upon these changes in energy density. So let's talk about that, what that really means in a little bit more detail. A typical rack today, 10, 12 kilowatt hours of capability. And then if we start to expand this into next generation racks, we're seeing 120, 140 kilowatts. And people are even speaking about 1 megawatt level at these sort of, so you can see this energy density going up. This means that right now traditional data centers have been cooled using air cooling. We use free air cooling, for instance. But at some point, air does not have the energy capacity anymore in order to withdraw that heat from the system. One of the basic things I tell my engineers, what does a data center produce? And of course, it produces all this great data for our customers and so forth, and all the wonderful experiences they have. But really, what we produce is heat. We take an enormous amount of electricity, and we convert this into heat, and we have to extract this as efficiently, as effectively as possible. For us, we call this a PUE, or power utilization effectiveness. Very simply, this could mean that it's the power that you put into a data center divided by the power that's actually used for the task that the customer needs, so our compute tasks. Any value that's close to 1 is ideal. Any value that is over that is being used then for cooling, for other types of auxiliary systems. And so we actually have systems that are as low as 1.04, which is so close to that ideal. And we want to maintain that capability as much as possible. And that's possible with air. But with these energy densities going up, you need to move to liquid. Why do you need to liquid? Imagine yourself at a beach. It's 30 degrees Celsius. It's warm, but it's not so bad, right? But then when you go into the water, even if that water and you're in the Caribbean and it's still 30 degrees, it feels that much cooler to your skin. And this is exactly what that liquid system will do for these new data centers to extract that heat. What we've done is that change will not happen as a step change. That change will happen over time. That change will happen. There will be a percentage of air and liquid. One of the challenges that we did is how do you bridge the gap? We know eventually it'll all be liquid, but how do you bridge the gap? And so we developed what we call our in-row heat exchanger. Our in-row heat exchanger is a closed cycle system. It takes the liquid, brings it to the silicon, cools the silicon down, and that liquid then is returned again, brought across some copper, and then we actually blow the cool air across it, and that air is then extracted, the heat is then extracted into the hot oil. And all of that is then just recirculated. Hardly any water loss, because obviously water is such a precious resource. We want to control that as well. And so this allows us to very quickly place a liquid-cooled system in our existing infrastructure. From whiteboard to having the system up and running, less than 12 months. This is the speed also that's expected from our customers.
Wow.
If we think further with this and go that next level down in terms of the silicon that we use, our graviton chips use 60% less energy than typical processors that you can buy on the market today within our software environment. If we think of our Trainium chips, specifically designed for training and aspects, 25% less energy. So we look at the entire stack when it comes into this. We look at controlling as much of that stack as possible. But with these changes come a lot of development that needs to happen, and therefore working with a great partner like Siemens is so incredibly worthwhile and necessary to move on to the future. So lots of work to do.
It is. And may I ask the two of you, because I think that's really interesting. from your perspective, what is the hardest to solve at the moment? Is it like the cooling? Is it the power? Or is it just really the speed of deployment that needs to happen?
You want to go first?
They're all difficult. So they're all hard. And what that's the great thing about it. You're looking at a full system aspect of it.
Yeah.
I think from a cooling side, liquid is something we've been primarily air-cooled. Everybody else has been primarily air-cooled. Obviously, we have a lot of experience with liquid cooling in southern regions, say, for instance, our data centers in Singapore. But I would say, really, it's looking at it from that system side and at the same point, getting that PUE, that power utilization effectiveness, down as low as possible, and of course, scaling for our customers' needs.
Yeah. And to build on that, I would totally agree. I'm like, each task in itself is reasonably complex. The real difficulty and challenge, but also the beauty, is in the optimization of all these parts and pieces, because we're tweaking a multidimensional system. This is no longer just engineering, just cooling, just compute. There's renewable considerations in there. There's uptime considerations in there. And tweaking all these buttons at the same point of time, that is the big challenge, because that requires a lot of factions to work with each other that are not used to working with each other in that form. So I'm like, honestly, it's to some extent a human challenge. And to do this with speed that he needs, in innovation cycles where our engineers in Siemens, to be quite frank, we're used to working in years, right? When we bring new products in the market. Now to do the same in 6 months forces us to completely rethink how we work.
I can only imagine. But as you said, like, what a time to be an engineer. Like, it's
Yes.
very exciting. Joern, I would stick with you for a second. In what ways would you say are you using AI in planning, constructing, operating these data centers?
Sure. I mean, a company needs to, like I say, eat your own dog food, right? So
Correct.
We build these AI systems, so therefore we have to use them as much as possible. First of all, AI is driving our needs from our customers. So that's one piece where AI is bringing that in, is our customers' needs. Our customers' insatiable need for this type of system. We're not just building this as greenfield. We can't sell this as fast as we can build this. So let me give an example. Last year alone, we implemented 3.8 gigawatts of installed power capacity, equivalent power capacity for data centers. That is larger than any other hyperscaler. So, and by 2027, we're going to double our entire capacity again. So we're nowhere near done. Like, this rate of change and this rate of deployment, this rate of capital expenditure is just massive in this particular field. I can give another example here in terms of construction, of how we're building our data centers. We're just launching our new Titus version of our data center. And the Titus version is specifically designed for starting to bring in these hybrid, more power system that Ruth was speaking about, the higher power densities that we need. So for instance, 6-fold the power density in our rows than we had in our other data centers, which means updates, everything on our power distribution cabinets and everything else that's bringing in the power into that line. In these data centers, at the same time, we're trying to reduce our energy signature. So 46% reduction in mechanical power usage for the fan usage. Massive reductions. 20% reduction in low carbon steel usage, and also reductions in terms of low carbon concrete that we're putting into these centers. So that's another piece of where AI is driving even just overall the design of our buildings. Finally, how we use our software. We use AI software to optimize exactly where the servers need to go. This has given us 12% more power capability, compute capability within every one of our buildings that we're using this type of technology on. So it's used across the entire spectrum. Everything from the demand from our customer to how we design our data centers to how we optimize the internals of our data centers.
That's really exciting. Do you want to add to that? Sorry, I didn't want to interrupt you.
No, I'm like, I can continue building on this and how we can support customers and partners like AWS doing this. When you look at our Siemens portfolio, we're uniquely positioned because we have a lot of building blocks that are needed here. But when you think about the design challenge, and again, back to this engineering marvel that we're trying to build here, doing this with speed, there's no way around digital tool sets. It needs to be software-based. It needs to be simulation. It needs to be different disciplines coming together. And that is where we are lucky that we have an incredible software portfolio that supports whether that's SimCenter, whether that's our digital twin technology. that's where it starts. There is no other way. With pencil and paper, we will not solve this challenge that we have ahead of us in the speed that is needed. But it's not just this independent discipline approach about optimizing cooling of power, or sometimes it's as basic as placement, right? How do I build a data center when I need to lay electrical wire and pipes and place equipment without people stepping over each other? So this is like gaming technology, right? How do I optimize this? And of course, there AI comes into play. What's the best path of doing something like this? Yeah? I talked about cooling, heat transfer, how to design the chip, and then how do I optimize the chip, the rack, like the server room, maintain airflow, cooling flow, things like that, while at the same point of time simulating my cooling system to prevent leaks. That's the next piece. Then we talked about the overarching task of an AI data center as maximum compute result with minimum power consumption. That's the equation we're trying to solve. And that means that all the automation systems that historically used to be separate, they all need to come together and work in unison. And that's where we are, again, in a unique position, because Siemens happens to be in all these businesses very actively that need to come together here and need to be in harmony and in an optimized fashion to solve the problem. And from our perspective, I'm like, clearly partners like AWS are key, but we can't do this ourselves. I'm like, we're working intensely. I'm like, with computing partners like, I'm like, of course, NVIDIA, everybody around in this industry, cooling technology. I'm like partners that are in the battery space talking about resilience. And I think that is something also, this industry needs to come together. This industry needs to rally, because this is a big, big, big challenge that no company by itself, I believe, can solve today.
It's really amazing, and it's also incredible how much technology is needed to solve all those challenges. So thank you so much for elaborating on the technology background on it and how we can help partners like Amazon. So looking ahead, I mean, it all sounds exciting, but also very futuristic. So if you look ahead, like in the next 5 to 10 years, we expect to see that explosive growth in AI demand and AI innovation. And Joern, what are Amazon's key priorities related to this technology?
Sure. If I personally were to look at AI, and first of all, from that very top 100,000 foot level, what does this really mean? And a lot of people speak to this as, is it a bubble? Is it all of these other sort of things that might be there? To me, it's a technology or it's a development path that is unlike my generation, my parents' generation has ever seen. You really, in my opinion, have to go back to the Industrial Revolution, the development of the steam engine, when you see a technology that has such revolutionary potential effects on humankind. And to be part of that, building the machinery for this, is, to me, absolutely amazing. And so what an incredible task that we have in front of us in the next 5 to 10 years. I can tell you from a principal level at AWS, we will always be, 5, 10 years from now, very customer-centric. Number one is what our customers need for this. And looking at that, decomposing that, they need the reliability, the resilience. Ruth already spoke to this. They need our global scale that comes into this. And they need the speed of innovation that we're putting into this. So let's give some examples here. We have a Project Rainier. Project Rainier that we built up last year, 500,000 GPUs deployed in 12 months. We'll deploy another 500,000 GPUs in another 12 months. It's just part of that 3.8 gigawatts deployment schedule that we have. While doing this at this pace and at this speed, we're also looking at that resilience component. And from there, we're very multi-layered. We will always still have our regional concept, our availability zones within each one of those regions. And that's just to describe that we have clusters that are within about 100 kilometers of one another. And that's to make sure that there's no local disturbances, that we can shift very quickly, but still keep that customer capability and the computational performance that they're looking for in something like this. And then obviously the data centers then that sit in these type of clusters. When we look at the reliability, you mentioned battery systems. We eliminated UPS battery systems, centralized UPS battery systems many years ago. Why? To reduce what we call blast radius, to reduce that as low as possible. And we replaced it with battery backup units directly on the rack level. And so with that, if one of the batteries fails, we don't take down multiple rows, we just take down a few servers into that rack. And so a lot of our thinking will always be in that centralization. Obviously, when we move to best technologies and with the coherence that you're speaking of in terms of the power signature, that starts to look at brand new methodologies that we can start to think about how to create a centralized battery system into that scope. Again, super exciting work that we're putting in. And so so our reliability will always be the same, that expectation. And we go right to 6.9 capabilities right now, actually, at AWS. It's one of the highest, if not the highest, within the industry in terms, and that our customers will expect and continue to expect from us. I can tell you for sure, for certain, that if you were to walk into one of our data centers today, and then you start to walk into one of our data centers in 5 years from now, because of this massive change in energy density, it will look completely different. Yeah. You'll still see servers, obviously, running and humming away. You'll see a lot of power equipment that'll be there. But the way that that's architected, the way that that's placed together will be completely different from what you saw today, which is so different than if I were to go back 5 years and say, hey, if I walked into a data center in 2020 and walked in one today, they look more or less the same. This is the big change, I think, that we'll start to see in the amount of innovation that we have to do. And we can only do that with partners.
Yep. That's amazing. And Ruth, for Siemens, where do you see, like in the future, Siemens heading in data, like in the area of data centers?
Yeah. So for us, of course, enabling AI through infrastructure is one of the key focus areas. But of course, at the same point of time, we're working very actively on leveraging AI for our own portfolio. And whether that's design, simulation, our automation frameworks, industrial co-pilot, we got to do both, right? Enable it, but use the technology, adopt the technology ourselves. So that is key. Fundamentally, I agree with everything that Joern just outlined. There's a lot to unpack here, but I'd like to add to that as well, because it's not just about making AI available. One thing that we're all driving past right now is the challenge of sustainability and the challenge of energy consumption, water consumption. Building out AI at the speed that we're currently working on will have an impact on the environment. And that, at some point, we need to bring that back in check, whether that is through use of different chip materials, more energy efficient materials than we're using that today, whether that is about waste heat, recovery in some different forms or fashions, it's cooling changes and cooling temperature changes, the use of different power sources. And we have a couple of those partners that we're working with very actively as Siemens to add green energy at scale into this equation. Will be the next consideration. One thing we haven't even talked about is refurbishing of data centers, right? What's the average lifetime of a data center? 8 years? Then you rip everything out and got to replace it because the technology of the industry moves so fast. What do you do with all this equipment? There's a lot of precious metals in there and minerals that you want to reclaim and recover. So honestly, I think we haven't even seen touched the surface of all the business models and business opportunities and engineering and technology challenges that will develop as AI grows and really becomes a part of life. And we honestly, in Siemens, we look at AI as a similar impact to the invention of electricity. At some point, AI will be a household good, and we will not be able to imagine a world without anything AI related. So,
absolutely. And you already kind of put it now into perspective. But how would you say, what big of a role does the whole topic of AI infrastructure and everything behind it fit to the Siemens AI strategy? Like, how big of a deal is it for the roadmap ahead?
For us, huge, because again, it is a big business opportunity, of course, that we would like to capture. But AI is also crucial for us to fine-tune our portfolio and specifically those digital tool sets that are so important to enable the growth. We need to adopt those ourselves. We need to implement really actively AI, and what we do as a company and what we offer to customers like AWS to become really successful.
Absolutely. And Joern, same question to you. For Amazon, for AWS, how do you see, like, how crucial is it to realizing also your AI strategy for the company?
Sure. AWS, it's no secret, it's a great growth engine for us. So it's right now we're the world's largest cloud provider in terms of percentage. Obviously, we want to maintain that hold in that position and keep serving our customers the way that we are. So it's of tremendous importance to us to maintain that speed and that capability that, as I said, our customers expect of us. And so a lot of fun ahead for the decade to come.
Absolutely. And maybe last question, like, can we expect many great things going forward between the partners, Siemens and Amazon, when it comes to data centers?
The task is too large. This is not something that one company can do by itself. And to have a great partner like Siemens at your side that we can work together with and develop these technologies, I'm very much looking forward to this cooperation.
Yeah, same here. And we have not even touched on one area that I think we also at some point need to bring into consideration, and that is that of workforce development and the impact AI will have on our workforce. Because when you follow the news, and there's a lot of concern about, is AI displacing jobs? And realistically, AI will displace jobs, but the jobs that are grunt work, right? To me, I look at it as AI, and what we're seeing right now in the United States is a massive opportunity to upscale our workforce, train people, educate people, really have societal impact. And right now, I'm like, just this speaking for Siemens, with the investments we have made, and I'm sure yours outpace ours by I don't know how much. We're actively generating jobs right now. We're generating attractive jobs in a country that has at some point lost its touch with manufacturing. So the impact AI will have on the United States and on the world far outweighs just all the topics that we just were able to touch on here.
Absolutely. Great. Thank you so much for this very insightful conversation. Also, thank you everyone for joining us today. We wish you a great day. Thank you for joining in. Bye-bye.
Thank you.